Get out. Argo, I'm here, I'm working. Thanks everybody for coming here. We wanted to show a demo of something that we built using Terraform. Terraform for on-prem stuff, which is kind of, almost an oxymoron in a sense, but we kind of want to show the ins and the outs that we went through to kind of demonstrate something like this. By cloud, we mean Google. We are a Google company for our hybrid solution, so Terraform was obviously the brilliant choice to kind of build on our Google footprint and our Google data centers. Wayfair and GCP, I want to go back to last year when we actually started this endeavor. So a couple colleagues in the room, they were tasked with, hey, we're going to build a couple data centers in the cloud. And we started having the discussion of, okay, does that mean two teams? Does that mean a cloud team and an on-prem team? Because we already have a legacy footprint and pipeline of how we're building things. We kind of started the theory crafting of, well, we should use one or the other and kind of collapse the stack. Are we going to take the on-prem stack and forklift it up to the cloud, or are we going to kind of do the cloud way of things and reverse engineer how we're doing things on-prem? And obviously the latter is what we chose. You are going through quite a lot of spider webs of what you're going through legacy-wise, but it forces you to update your on-prem to match modern technology. You're going to find quite a lot of memes in here, so I kind of went crazy. Let's go forward here. So, we decided we needed cloud. We needed tools to do it. HashiCorp, thanks. Like, awesome work. It made it much easier than we expected. So, once we kind of figured out that stack of Terraform and Packer and Console and Vault and how it meshed cleanly with our Puppet House, we started building stuff. And then we said, okay, we are a big data center in Seattle, we're a big data center in Boston, we're a big data center in Dublin. We want to spill over into the cloud when we need things. We're an e-commerce company. We have a pretty cool day-to-day, and then Cyber Monday comes and stuff gets absolutely ridiculous. So do we buy a bunch of servers and let them sit there for plus 300 days out of the year, or do we have that spillover capability where we can have our more or less planets of our original infrastructure, and then we can spin up these moons just to take care of those quick, crazy days? So first things first, I want to kind of start at the very beginning here, and I call this my Legend of Zelda dungeon map, and it's going to make sense in a second here. We knew how we wanted to build the cloud. We knew the right way to do it. We had plenty of people to almost kind of watch their journey, how they do it. We had to actually go back and see, how do we build our on-prem stuff, and how big of a change is it going to be to build on-prem like the cloud? So we got a bunch of people in the room, and we did a value stream map. And we said, if I need a server, and I'm a business person, and I think of this, and I put in a ticket, how long until that server is in prod doing work? And we found that, you know, the average for a SQL server was 49 days, and tickets were going back 13 times between teams. That was the legacy pipeline that was us. That's how we produced machines on-prem. After that, we said, how many tools are we using? We're 12,000 servers. We're 3 major data centers. We're 2,000 engineers. We're giant. We almost can't stop people from using the latest tech just to get their business value out there, to get their feature out there. If you see a solid color across the line, we're good. We kind of match up on that stack. If you see multiple columns or multiple colors on a row, that's when we're seeing, actually it's not coming through too well here, so I apologize for that, but it's more or less that row is not unified, and we had to have almost a couple hard discussions of what tool are we going to use, because we can't support both in some of the instances. But in the end, we had to build GCP machines, virtual machines on-prem, and physical machines on-prem, and we wanted to use the same tool stack to do it through and throughout. This one I love. So we're almost discussing like the pros and cons. Do we refactor some of the on-prem stuff to prep it for the cloud because we know it's going to be expensive? Or do we just forklift prod up there, see what the bill is, and then do the refactor later? Will we have the time to do the refactor later? So we came up with a project name, internal project name, Argo. This was our goal for hybrid cloud. How to get on-prem automation similar to how we're doing GCP automation and eventually collapse that code library into a single thing. And the one thing I got asked right when the name came out was, how the hell did you come up with this name? Because everyone thought it was this. And this is absolutely not the case. It was actually the CTO that came up with the name. And we said, okay, maybe he's a Ben Affleck fan. But more or less, he followed what Amazon did with their Apollo, with Netflix and their Spinnaker. There's almost a Roman Greek background to the name. So the Argo was the ship in Jason that traveled the world, and the ship actually had an eye in the front. And the kind of analogy there was the ship was just as important as the sailors and the soldiers on the ship. So the top is what we decided on for our GCP pipeline. You do a git merge request. Jenkins via Jenkins Blue Ocean is what we're using. Takes that, uses the Terraform plugin that talks to GCP, and the GCP plugin for Terraform has everything that you need. Network, VPC, firewall, you name it, you can build your whole data center with that plugin, essentially. Once it does that plan, it says, here's what I'm going to do, whether it's an add or a modify or a delete. Do you want to apply that? Yes, merge, request that, and it applies, and it builds your infrastructure. And we wanted to kind of plagiarize that on-prem and find the missing bits from that previous map. What did we miss to kind of fill in the gaps and follow essentially the same plugin? So what we built is essentially these boxes in the middle, and these are Terraform plugins that you're going to see right after this when I hand off. It's a framework for basically a Terraform communication protocol to anything with a REST API, and just about everything in our data center came with a REST API. So git merge request, Jenkins Terraform, runs the plan, talks to Device42, which is our IPAM solution, can talk to EMC storage and add physical LUNs or modify LUNs, talks to Foreman, which is our Pixie boot process, can talk to Cisco ACI network because it has a REST API in front of it, or any other network kind of software-defined protocol you want to put inside there. The nice thing about this plugin is we can rip out Cisco and put any other network solution inside there, and it's a simple modify of the plugin just to adapt to that new REST API. Tufin for firewall, HP Dells for either ILO or iDRAC direct communication, and then vCenter has actually a pretty lovely plugin for the open network GoVC. If anybody's ever used it, it's actually pretty fantastic. So started building these, started piecemealing these together, and we thought, okay, let's test the engine. What can we do here? But let's dive into those pieces first. I'm going to introduce Brendan McGarry. Brendan.
All right. So for the Wayfair people in the room, this is going to be pretty much the exact same presentation that I gave during the SRE All Hands, so I apologize if you didn't enjoy that presentation. For all the new faces, my name is Brendan. I've been working at Wayfair for a little over 2 years now. I started off actually in finance engineering doing things for AP automation, but I was getting kind of tired and frustrated in that role, and I started looking around for other opportunities within and kind of like move laterally in the company. I interviewed with some places like with NOC and Storage Tech and didn't really find anything that really interested me. And then I went over to SRE and Jeff found me, and he was kind of like, whoa, cool, actually in SRE we're looking for developers, you write code, right? And I'm like, yeah, I write code, but really I want to fiddle with computers. He's like, well, actually there's this really cool thing I thought of called the project, the Argo project, and it's going to change the world as you know it. Do you want to write code that fiddles with computers? And I was like, yeah. And so here we are today, and I was kind of one of the lead developers on all of those Terraform plugins that Jeff was just talking about. What I wanted to go through today is kind of like the core ideas and principles that we had going into this project that I kind of brought to the team to try and make this as fast and as well developed as we could. I boiled it down to these 4 core principles. I'm going to go through each one one by one, starting with do your job. So what do I mean when I'm talking about do your job? Typically we're talking about isolation, do one thing, do it well, Unix philosophy. In system engineering, we kind of have this idea of coupling and cohesion. And in the infrastructure world, we have this idea of pets and cattle. And what we strive to do is get things that are cattle. We want single purpose machines that we can scale horizontally, indefinitely. We want very tight zones of trust. So when we think about how we're going to develop these Terraform plugins, we're going to apply the same principles. To do that, we had to kind of think about what does Terraform offer us, right? Our software is a solution to a specific problem at a specific point of time. So what solution is Terraform offering us? At its core, Terraform is just a state manager and a difference engine. And that's pretty much it. So we've got to architect our plugins in a way that exploits this pattern. What we do for the plugins is we kind of implement the builder pattern. Design patterns 101, if you need a refresher. The builder pattern is the idea that we separate the construction from the representation of the objects that it's modeling. In addition, when we architect these plugins, we developed a concrete and separate API package for each one of these APIs, which kind of gives us our own little personal Go SDK for each one of these. So if we kind of look at this in action and kind of really see the benefit of what's going on, this is for the foreman provider, and we're looking at the architecture resource. On the left-hand side, we can see our implementation of the builder pattern. At the top, there is the build function, which basically will just take the Terraform representation of the object and translate it into something that our API layer can understand. And on the bottom, we have the inverse of that operation. So give me an API object, and I'll translate it back to something that Terraform understands. On the right-hand side, you can kind of see how with the builder pattern and our separation in the API layer, we really have like really minimal and simplistic code. Even if you've never written code in your life, you've never even looked at Go before, you kind of understand what's going on here. We get a client, we build something, perform an action on the thing, write it back. And that's pretty much it. This gives us several benefits. For one, if Terraform goes away or Terraform is no longer the best solution to this problem, we're okay. We can basically move the builder and the setter up to the new tool, or move our API layer with it. We're good to go. Keep going. It also gives us flexibility in the API layer. If we have third-party APIs that are well supported, or we find a better API implementation, we have that ability to plug and play, right? It's cattle. Throw it away, get the better cow. Also gives us some benefits in terms of backwards compatibility. So in the API layer, if we're supporting an older version of like Foreman or Viper or whatever, that's fine. All that is handled by the API layer. Terraform doesn't care, right? It's just implementing this API and going over that kind of trust concrete boundary. Second thing that I want to bring up is logging. So when we were originally developing these plugins, Terraform has some built-in logging behavior, but we quickly found while we were developing that this didn't really service us as well as we liked. So one of the things we noticed is that the Terraform.log file that's generated on each run contains logs from all of the providers that were used in that run, which is fine. But the other thing we noticed is that the tflog environment variable that is used to control the verbosity of the logs basically overrides and suppresses all of the logs from the providers, which is good in some sense, but not in others. I'll show an example in a second. So what we're looking for is being able to log what is useful to me. And what I mean by useful is basically we want to separate the message from the context of the message. We want this behavior to be toggled quickly and efficiently. And so what we ended up doing was implementing our own logger package that supersedes or is a superset of the Golang built-in package. So if you kind of look at this Terraform.log file, you can see that everything is prefixed with this tflog environment variable, and Terraform is automatically tagging all the provider log messages as debug. And as you can see, there's a ton of information here. Not all of this is really useful. Really, everything from this point on is useful to me. And this is just for one provider. If we have 4 or 5 providers going in that pipeline on a single run, it's just going to be an absolute disaster. So what we ended up doing is when using this, this new logging package is the only things you'll see from the Terraform.log is basically where are we logging? What threshold does that log go to? Okay, cool. Everything else is committed to a separate file. We don't have to worry about that. It makes it easy to find what we're looking for. We also have log levels that can be independent of the Terraform log environment variable. And all of this is configured through environment variables or through the HCL configurations passed to each provider. We're also looking at doing things such as logging to Kibana and making some cool charts and stuff because NOC folks like that kind of thing. Next thing I want to talk about is documentation. Bit of an awkward subject, especially in SRE. There are a couple, I guess, excuses or reasons why people don't write documentation, and none of these are necessarily invalid. It does take a lot of time. I mean, if you're a manager, you don't write documentation because you're busy doing whatever managers do, meetings, charts, whatever. If you're an L3, L4 engineer, you're not writing documentation because that's for the L1, L2 peons, and you have better fish to fry. If you're an L1, L2 peon like myself, you don't have time to write documentation because you're too busy picking up tickets and moving them around and knocking out features, bang, 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 one by one by one. You know, it's agile. You know, welcome to agile. Everything's made up, and the points don't matter. So, I think the core issue, though, when it comes to documentation, is that it's very monotonous, it's very repetitive, and it takes away from doing other meaningful work. So, what do we do when we're faced with a problem that is monotonous and repetitive? We automate it. So what I did is I wrote a little binary or a little application that basically generates for us automatically on git commit documentation for each one of our providers. It plugs into our MakeDocs pipeline on-prem. So that means if you're not familiar with MakeDocs, it's a Python tool that you can use to generate documentation, uses YAML and Markdown. The engine itself just basically used a lot of the tools that already existed, so the text template library from standardlib, and all of this stuff, yeah, like I said, on commit, automatic, make stock style documentation. It also generates GoDoc for all of our providers, so if you're a developer and you want developer resources on what are the public interfaces, what are the API models, how is everything working, all that is there for you as well. And our MakeDocs pipeline also separates dev and prod documentation releases, which is really useful for feedback cycle. So the general idea here was I wanted to make it as minimally intrusive as possible. The basic idea is you define some templates. You create an autodoc binary, a simple little main that basically you pass your provider to, say, hey, document this for me. Basically, the tool will pass certain data and expose it to your templates that you can then use to make documentation. Here's an example. On the left-hand side, we see documentation for the provider itself. So it has information about what this provider is, what are the arguments, how do you use it. In the middle, you have the GoDoc. So if you're interested in all of the packages, how they work, that's there for you too. And on the right-hand side, we see documentation for each one of the resources and data sources that are used by the provider. So example usage, arguments, types, all that good stuff. So the basic idea here, right, is as we use this platform as a service and extend it out to Wayfair, we want to make sure that we minimize stupid questions. We want to make sure people are doing work, they're engaged, and kind of get that rapid prototyping cycle going. The last thing I want to talk about is testing. So Terraform right now does support integration tests. There are some limitations to this that we did not find particularly nice. For example, it needs to reach out to the appliance itself. So you have to have a dev, a lab, or a sandbox environment available all the time for when you want to do tests. It also does end-to-end tests, which is kind of like the integration side. But what we're more interested in is the actual unit testing, so smaller scale. So what we did is built a test framework that basically can mock the resource states and mock the API calls and responses. And all of this is held locally in the test data folder, which if you've done Go development is a special reserved path, which is really nice. So no outbound calls. And that pretty much wraps up what I wanted to say. In terms of what we're doing and more to come, we have a shared utility repo that is leveraging, all the providers are now leveraging, which is really nice. We're continuing to expand our test coverage, refactoring for low coupling, high cohesion, and also looking into doing more things to help developers get started. And that was pretty much all I had to say, so thank you.
Hey yo. Quick introduction, my name is Daniel. I have to apologize because I have an accent. If you have trouble understanding, I haven't lived here long enough to develop my American accent, so apologies. So what I want to talk about is, basically using all these cool providers that Jeff and Brendan just described. So the way we do that, we wrap them in a module. I don't know if many of you have used Terraform before, but modules give us great control over these, what we want to actually, how we want to use these provider resources and data sources. So we can I guess, derive what we want from data sources to reduce the required knowledge that human has to have to provide to actually use these resources. So in our instance, we wanted to provision, be able to provision bare metal hosts as easily as possible. So the way we do this, we use this custom Device42 provider as our single source of truth. So we have a series of data sources that pull information from Device42 of our host. We use the Cisco ACI provider to basically allow us to perform network configuration changes and discovery of network configurations in our environment. We use Foreman for our Pixie provisioning of a host, and Viper for our storage automation and management. So what I want to do is, I've actually recorded, if I can get this up here, I recorded a kind of a practical run of this. So this is how we actually do this via a Jenkins CI process, but this is me interactively running this just to show exactly how this works. So let's just try and do this. Okay, so here we are. So this is me, I just have an IDE open, and I have a definition of basically this module. So these are the minimum required parameters that we need to actually provision a host. So what we do is, each one of these variables that are defined, they interact with different provider resources and data sources. So what we actually have here is, we have an entity name which will look up Device42, pull a bunch of information about the host. We have these three properties here which will basically pass straight to Foreman to define the host. We control the BMC operations against the host. So when you provision a new host in Foreman, you basically want to be able to send IPMI calls to that host. So it's a racked and stacked server in a data center somewhere. You need to power it on. You need to power it off to do a Pixie boot. And then our VLAN configuration, which is handled using the ACI provider. So the next step here, so I've broken up the screen into separate quadrants here. So if any of you have used these tools before, basically it's just the UI of these things. So in the bottom corner here we have Foreman. Just to show you, we have a host group here with no host defined. This corner here we have, I'm actually connected to the management interface of a host, powered off right now. This is ACI, so I'm just showing the VPC configuration, LACP policy setting for that host. I'm just showing that there's no VLAN defined for that host. Okay, and then here we have Terraform. So I'm doing a Terraform plan right now. So using our module, pause this here, you can see that it says we have two things to add. So basically that means it's trying to add the Foreman host and the network configuration for that host. Okay, now we're going to perform our apply. We're going to confirm. And apply complete, two added. Now it'll jump to the Foreman window, we're just going to refresh, and you can see a host appeared. What actually happened in the background there is that actually performed an IPMI call against that host. So we should see, there's our network configuration, we should see our host start to boot up down here. And there we go. Now I've sped up this process because if anybody's worked with physical hosts before, they'll understand the crazy amount of tests that have to happen. So we're running times 30. I was actually considering putting some Benny Hill music on here for this process. Here we go.
When you push F2.
Yeah, so here we go. So this is actually running via Kickstart, our host provisioning process. This is all via Foreman. There we go. So this is kind of a little bit out of order, but what I'm trying to demonstrate here is, let me just pause this. So one major hurdle that we had is we want to enable or disable LACP when we're doing this. When you enable LACP and your interfaces are channeling, it's very hard to re-provision that host via Pixie. So we needed an easy way to do that without having to interact with our network team and hit those guys up with tickets and then wait for X amount of hours for that change. We wanted to do that ourselves. So the way we exposed that is with this module, we basically expose it as a Boolean value. So in the back end, a bunch of changes are happening in ACI via resources that just toggle the LACP policy for that interface. This is me demonstrating applying that change now. So toggling that to true, I'm going to do a plan and apply here. You can see it's Wayfair convention, but basically our policy name we've changed from a no suspend policy to the default policy, which is LACP enabled. And then apply. One change made. So now it's just demonstrating that the change actually happened in ACI. Policy change is now default. Host is booting up. Speed up again. And there we go. Host configured. I'm going to try and show you next here. Any questions on that process before I go on to the next step? So today, this basically is about a month old, this video that I showed you here. Today we have a slightly more evolved process. It's relatively similar. But this is just an example of a live build that we did today. So we did this through our CI process. I'm going to try and log into this and show you. This is a build of 3 stores boxes we built today. So through Git, somebody else in a completely different team that didn't necessarily know how any of this worked was able to just submit this merge request. And it defined 3 hosts, 3 separate modules, calls with the required arguments. Somebody on our team was able to approve that and kicked off a pipeline. It looks like this. You can see we do a few other tests in here, kind of in-house built testing to make sure that no crazy changes happen. But here's our plan in the end. So for 3 hosts, we basically have 5 resources to add. So we add some definitions in device 42, we add the actual host in Foreman, and then the ACI changes. And then our apply. We do a quick run to import any resources that may already have been provisioned. Fortunately, because we built these providers ourselves, we're able to structure IDs and things like that in a way that makes sense for us. So here we are. Creation complete. Any questions on that?
So did that go live today?
It's been live for a while now. We've built maybe 30 hosts, I think now.
No, I mean those 3 hosts.
Yeah, they went live.
They're
Yeah.
serving traffic right now.
Yep.
So you didn't have to file a DBA ticket to get it put into table DB location?
We've automated that as well.
Oh.
We have obviously a few more TV issues to work out there, but it's more or less end-to-end ready to do this.
The goal is to talk to the least amount of people as possible, basically.
Yeah.
Any other questions?
So I have questions, but I can save them until the end if you have more presentation.
A couple more slides,
Yep.
and then we can head out to the kitchen for a little bit more of a,
Sure.
cordial question.
We are going to open source all of these plugins and even the skeleton framework of what we built for these plugins.
That was one of my questions.
Yes, it is absolutely going to open source. We're going to have a tech blog article that goes live for the Wayfair tech blog. Cisco was actually in-house here a couple weeks ago, and I told them we were going to open source this. It was a bit of a deer in headlights moment, which kind of felt good, but it is what it is. Yeah, so we're going to open source these. We're going to open source the static. All the slides we had, it's going to be on the meetup. Blog post we're going to have for kind of like an additional rundown for this. One last thing I wanted to go through is, if you look at this comparison, this is kind of, you're signaling in on a very minute part of the process. And it's very similar to a single day on the stock market. So that pipeline you saw is 1 day on the stock market. And what we want to do is actually expand out with our global plans for everything that we showed you today. For reference, this is Wayfair stock for the past year. This was the start date of the Argo project. That's where we are now. I'm not saying there's a correlation, but you never know. There's something going along with it. But eventually what we want to do is merge these into a single hybrid pipeline. So it is the same stack. And we can just pass a Terraform variable that says, I want a GCP machine, apply. Or I want a VM that's on-prem, apply. Or I want a Boston, Seattle physical machine, apply. And it's the same interface that everybody's going through. This couldn't have been done without like a huge amount of people. Probably some of the smartest people I've ever worked with in my life. Like kudos to everybody that put into this. Tons of languages. God knows how many code commits we did to this. A year's worth of work. Like awesome work, everybody. This was a phenomenal thing. And finally, we are having another conference here in October 12th, actually 11th and 12th. Here's my email, Jeff Dillon, jdillon@wayfair.com. We're obviously hiring in several teams. Feel free to let us know if you're interested. Boston S3 conference on the 12th. Because you fine folks are here tonight, if you enter this code, you do not have to pay. The conference is free for you. So enter thanks sponsors, but it was a big thank you for Splunk and ThreadStack, and who was another sponsor that we had, Hamans?
GashPoint.
Yep, GashPoint. So thanks for everybody. We're gonna have Liz here, who is pretty much an awesome speaker. If you've never seen her or any of her YouTube videos, it's probably one of the best talks I've ever seen. So really excited to have her here. And thanks again, everybody.
So,
Questions? You want to hang around the room?
Sorry, we can ask one or two.
Go right ahead.
Yeah.
So this is going to be a classic statement.